In the previous video, we looked at generating the sample path for our single server queuing system, and so you can see that we have the let's see, let me get my pen here. We have our single server and we have the queue, and in this case we have entity 3 being served and entities 4 and 5 in the queue waiting for service. And we talked about the representation of the system state as a combination of the entities in queue and the entities in service. The two types of events we're interested in are arrivals and completion, and then we generated the sample path by using the arrival and service time data that we were given. In this video, what we're going to look at is how to extract performance information from the sample path. So let me see if I can erase some of this stuff here. I don't need that anymore. Well, there we go. And what we're going to look at is something called sample path analysis. And so for this model, we're interested in two different types of information. We're interested in entity-related information, entity-related, and system-related. System-related. The entity-related information we're going to look at is the time that an entity spent in the queue, which I'm going to refer to as TIQ, the time that an entity spends in the system, TIS, and the system-related information that we're interested in for this model are the number of entities in queue, I'm just going to call that NIQ, and the server utilization, which I'm going to refer to as rho. So what we want to be able to do is look at our sample path and estimate these values, or we're going to get the exact values actually for our sample path, and then we'll use those to estimate the overall values. So let's start with our entity-related values, the time in queue and the time in system. So let me erase this, guys, and let's look at these issues of time in queue and time in system. From our sample path, for each entity we can determine what time it started processing, what time it completed, and then once we have this information, we can compute the time in queue, which is simply the start time minus the arrival time, and the time in system, which is simply the completed time minus the arrival time. So we can, for each entity, get TIQ and TIS. And so if we look at E1, E1 arrived at time 0, and so it immediately started processing. And then we can look for the completion of E1 event, which happens here at time 5. The time in queue is simply the completion time minus the arrival time, which in this case is 0, and the time in system is the completed time minus the arrival time, which is 5. For E2, we can see the start event, E2, happened right here. When E1 completed, E2 started at time 5, and E2 completed at time 6. And so the time in queue was the start time 5 minus the arrival time 4, or 1, and the time in system was simply the completed time 6 minus the arrival time 4, which was 2. And so this tells us that the entity spent 1 time unit in the queue, 2 time units in the system. For entity E3, we can see that it started right here at time 10 when it arrived. It completed at time 13. The time in queue was 0 because it arrived and there were no entities in service, and the time in system was 3. And so you can see we can read all of the entity-related information directly from the sample path. So if I skip over to this page, we've extracted all of the information, and so we can see the two that we computed for entity 1 and entity 2 right here. And I just followed that same logic through to get the 10 observations of time in queue, 1 for each entity, and the 10 observations of time in system, again, 1 for each entity. And then we computed the summary statistics by just averaging the individual values. And so this entity analysis tells me that on average an entity spent 1.8 time units in the queue, and on average an entity was in the system for 5 time units. These entity-related statistics are often called observational statistics. Observational statistic. And in this case, there's a single observation of each one for each entity. And all of these observations are equally weighted in our final analysis. For the system-related analysis, again, the two that we're interested in are the number in queue, the number of entities in queue, and the utilization of the server. And so we're interested in, let's do number in queue first, what I called before NIQ. The analysis is a little bit different. What we need to do is we need to track the number of entities in queue over time. And so we have time on the x-axis and NIQ on the y-axis, and we have values of 0, 1, 2, 3, and so on. And so we can look, what we're interested in is this column C. We're interested in the number numerical value. So instead of the dash for an empty queue and E2 and E4 and E4 and I5 and so on, we're going to use the numerical value of 0, 1, 1, 2, and so on. And we're going to track over time the number of entities in the queue. And so we can see here from time 0 to time 4, we had 0 entities in the queue. Then from time 4 to 5, we had 1 entity in the queue. So our behavior between time 0 to 5 looks like this. We have 0 entities from 0 to 4. We have 1 entity from 4 to 5. Then the queue remains empty till we get to time 11. So it's 0 up until time 11. And then it's 1 entity in the queue from 11 to 12. Then 2 entities from 12 to 13. This is a 13. And then finally 1 entity in the queue until time 14. Then we have 0 entities in the queue until time 16. Then we have 1 entity at time 16. And then we immediately go back down to 0 entities. So our 1 entity here at time 16 never actually occurred. It just shows up because we had simultaneous events and we chose to model the arrival first. Then at time 18, we have 1 entity in the system, and that is in effect until time 22. At time 22, we jump to 2 entities for 1 time unit, 23, and then at time 24 we're back to 0 entities in the system, entities in the queue. Sorry. At time 25 we go back up to 1, so this is time 25, and that is till time 28. Time 28 we have 2 again for 1 time unit, time 29, and then finally at time 30 we have 0 entities in the queue, and we have no more entities in the queue until time 40. And so we have the time profile. What we're interested in is the sum of these areas divided by our overall simulation time of 40. So if I just add these values up and take the magnitude times the time, so this is telling me that I had 1 entity in the system for 1 time unit. Same with this little block here, 1 entity for 1 time unit, 2 entities for 1 time unit, and so on. If we sum these values, we get 1, 2, 3, 4, 5. Then we have 4 here in our 18 to 22. So that's 9. Then 10, 11, 12, 13, 14, 15 here, 16, 17, 18, and we end up with 18 over 40, or 0.45 is our time average. So to get the utilization instead of the Q, we are interested in the whether or not the server's busy. And so if we use this column D, and instead of the individual entity, we just track whether or not the server was busy, and we do the same type of plot where we're interested in the, didn't want that. We're interested in our value over time, and the server in our case is either idle or it's busy. And you can see from our again from column D that the server is busy between time 0 and 6, from time 0 to 6, so it's processing entity 1 for 5 time units and entity 2 for 1 time units. Then it's idle between 6 and 10, then it's busy all the way till time 36 when we complete processing on E10. So we go from 0 to 6 and it's busy, and then 10 to 36, entity's busy, and then 36 to 40, the server's idle. And so if we calculate the value under the plot, we can see that it's busy 6 time units here, 26 time units here, so we end up with 32 total time units divided by 40, or 0.8. And so our estimate of the server utilization is 0.8. And for this sample path, what that means is the server was busy 80% of the time. So for these two, we did the analysis after the fact. In other words, we generated the sample path and then we went back and did the calculations. However, this is typically done as the state evolves. So when we're creating the event calendar or the sample path, we keep track of these values as we go. And so if we note these time intervals in between the events, we have the event time 0, 4, 5, 6. It's where one of these values change. So we went 0 here, and 4 we increase the number in Q, and at 5 we decrease the number in Q, and at 6 we decrease the number busy, and then at 10 we increase the number busy, and 11 we increase the number in Q, 12 we increase number in Q, and so on. So you can see that these event times are actually, as we have noted before, the simulation time at which some component of the system state changes. So if we go to the state results, you can see that we've set up this page to calculate as we go, where what we have done is we've added this notion of the busy number in queue, number in system columns, indicating whether or not the server is busy, and also indicating the number in queue. So instead of having the entity-based representation, we have a numerical representation in columns G and H. We also track number in system, so we could get not only the number in queue, but the number in system. Also note that over in column K, we've actually tracked the duration. So if I look at column K, it's this value A4 minus A3, so it's the interval between the event associated with row 4 and the event associated with row 3. And so what this value gives us is the duration that these three state values, these three states have these given values. So for 4 time units the server was busy, there were no entities in the queue, and there was one entity in the system. And then for 1 time unit the server was busy, there was 1 entity in the queue, and there were 2 entities in the system, and so on. So by multiplying the duration by the corresponding values, so 4 times 4, 4 times 0, and 4 times 1, we can get what is essentially the area under the curve in the previous plot, which are all of these areas, and we can sum those and then divide by the total time. And so you can see we have this summation of column L divided by our simulation time of 40, get my cursor back, 40 time units, and that ends up giving us the exact same thing that we got when we did the calculation manually using the plot. So you can see what we actually do as the simulation is evolving as the event calendar is evolving, we're actually tracking the individual values. And so as we execute the simulation, we can keep a running track of the performance metrics that we're interested in.